Welcome to conceptual example number 1. And here we're asked to find the direction of the induced current for each of the examples. The bar magnet is either thrust into the loop or it is pulled out. In case A, we have the north pole facing the loop and is pushed into this conducting loop. So you can imagine that this conducting loop is in the plane of the page. Now when I solve these kind of problems, I personally like to just draw two pictures. I have a before picture and I have an afterwards picture. So the before picture, we have the magnet over here. There's our north, and then we have field lines coming out of it like this, like this, like this. And then we have our loop. So here's our loop like that. And you can see that the one of these field lines is penetrating into the loop. And then the magnet is now afterwards pushed closer into the loop. And so we have 1, say 2, and 3 field lines that are going into our loop right about here like this. And so we see that we'll have now 3 x's penetrating into the plane of the loop. And so then what happens is the loop will then try to oppose this increasing field or flux into the plane of the loop by pushing field lines out. All right, and so by pushing them, we would have a field line that is coming out of the plane of the screen. And then to determine the direction of the induced current with these induced magnetic fields, we use the right-hand rule. And if you look at the video on the bottom right of your screen, you'll see that I'll be pointing my thumb out of the screen towards you in the direction of these magnetic field lines, and my fingers will curl in the counterclockwise direction. So therefore, our direction of our current is going to be in this direction, and so our current is counterclockwise. CCW is my abbreviation for current in the counterclockwise direction. Okay, so now let's go to B case over here, where we have the south pole that is being thrust into the plane of the loop. So again, I'm just going to draw a before picture and an after picture. So I have my south pole, and if you recall, field lines go from north to the south. So we have field lines that are going towards our south pole, something like that. And here's our loop, and so we have a field line that is leaving the plane of the loop like that. So I'll draw a little dot here. And then in our afterwards picture, our magnet is now closer, and so there are more field lines that are now penetrating from the loop. And so here I'll draw my picture here. There's my loop. And so I will have, in this case, 1, 2, 3 field lines penetrating out of the plane of the loop. So the magnetic field through the loop points up of the plane of the loop and is getting stronger in the outwards direction. So the flux is increasing out of the plane of the loop, and whenever we have an increasing flux, the induced magnetic field will point in the opposite direction of this original field. So therefore, it's going to try to push these field lines back out, or push them back in here, as I should say. So then we're going to be putting basically 2 x's to essentially cancel out these 2 field lines coming out. I'm always trying to go back to status quo. So here you notice I went from 1x back to, again, it had 3 x's, so I got rid of the 2 extra x's by pushing field lines in the opposite direction of what was increasing into it. And so therefore I was back to my status quo of 1x and 1x. Here I have 1 dot and 1 dot again. So now, using the right-hand rule, in this particular case, we're going to be putting our thumb into the screen, all right, and our fingers will curl in the clockwise direction. So our current moves in this direction along in the clockwise direction. So we'll write ICW for current in the clockwise direction. All right, moving on to example C. here we have the north pole of the magnet facing the loop, but the magnet is being moved outwards and away from the plane of the loop. So the magnetic field through the loop is pointing down into the loop, but is getting weaker and weaker as time goes on. So again, we'll draw a before and an afterwards picture. So here's my before picture. I'm going to have the magnet, in this case, close to the plane of the loop. So we have 1, 2, 3 field lines penetrating this loop of wire. So I'm going to draw in 3 x's, 1, 2, 3 x's. And then in our after picture, we're going to have the magnet further away, and we only have really 1 field line that is actually penetrating into the loop. So here's our loop right here again, and so we only going to have now just 1 x going in. So in this particular case, what's going to happen is when the flux through the loop is decreasing, the induced magnetic field will point in the same direction as the original field. So remember, we had 3 x's it wants to keep in status quo, so it's going to actually put 2 more field lines going into the plane of the loop so that we can have 2 more x's, so that we have 3 x's just like in our original picture. So then now, using our right-hand rule, our thumb will be pointing into the screen, and so our fingers will curl in the clockwise direction. So there we go. I'll show my current in here going clockwise. So ICW for clockwise current. Okay, now moving on to part D, we now have the south pole that is close by the magnet, and we have 1, 2, 3 field lines that are pointing out of the plane of the loop. So we're going to draw 1, 2, 3 dots for those field lines that are emanating out of the plane of the loop. And then as the magnet is moved further away, we only have, say, just 1 field line that is coming through the loop now. And so what we have to do is, again, keep everything in balance. And so what's going to happen in this case is the loop is going to create its own magnetic field lines to keep everything in status quo. And so you can have 2 more B fields that are induced out of the plane of the loop. So now, using our right-hand rule, our thumb points out of the screen towards you, and our fingers will curl in the counterclockwise direction. And there we go. We have our current going this way, going along in our counterclockwise direction. You should notice a pattern definitely from this. You can see that basically, if you switch the motion of pushing a magnet, say, into the page with the south magnet, for example, then pulling it out is going to do the opposite effect. So you went from clockwise to counterclockwise, and the same thing you saw with, say, the north pole being pushed in and then being pulled out. So anyway, that's it for example number 1.